Hi everyone, welcome to another episode on fractions. In this video, we'll be solving more complex questions on fractions. Now, the first question we have, simplify the following. We have 2.5 plus 3 whole number 3 over 4 all over 2.5 minus 3 whole number 3 over 4. Yes, we have this question. We want to simplify. At the numerator, you can see we have two factors at the numerator that we want to add. At the denominator also, we have those two fractions, but then we are subtracting them. So the next step now is to convert the mixed numbers to improper fractions. And in the previous video, we learned how to do that. Let's proceed. Here, what we have is 2 times 2, 4, plus 1, 5. 5 over 2 plus 4 times 3, 12, plus 3, 15. 15 over 4. So how we convert is that we multiply the denominator by the whole number we have here. 2 times 2, 4. We now add the results to the numerator. After saying 2 times 2, 4, add that 4 to the numerator plus 1, that's 5. 5 over 2, then minus 15 over 4. Since at the top here we have 3 number 3 over 4, it's that same number we have at the bottom. So the both will be 15 over 4, 15 over 4. So we don't have to do that again. So this add. Now, I want to find the LCM of 2 and 4. We said if you want to add two fractions, find the LCM of the numbers at the bottom. You can see there's 2 here and there's 4 here. Find the LCM of 2 and 4. And one of the rules of finding LCM is that if one number is a multiple of the other, then the LCM will be the higher number. For example, in this case, 2 and 4. 4 is the multiple of 2. 4 is a multiple of 2. That means the LCM of 2 and 4 will to be 4. To be 4. So that's telling us that if we want to find the LCM of two numbers whereby one is a multiple of the other, the LCM will simply be the higher number. For example, LCM of 3 and 9. LCM of 3 and 9. 9 is a multiple of 3. That means the LCM will be 9. That's the general principle. It's a general principle. So let's proceed. So the LCM of 2 and 4 here is 4. 4 divided by 2. The 2 you have here, that's 2. 2 times 5, 10. Plus 4 divided by 4, 1 times 15, 15. Over. Since we have exactly the same fractions at the numerator and denominator, we don't have to do it again. So we can just write it here and we say 10 minus 15. But then be careful, at the denominator side here, this is minus sign, not plus. So we have exactly the same fractions. So we just put a copy of 10 plus 15 over 4 here. But here to be 10 minus 15 over 4. Yes, plus and minus, so plus and minus. This is now equal to 10 plus 15 is 25. 25 over 4. Then over 10 minus 15 is minus 5. Minus 5 over 4. Now this is equal to. So the over here, we can see it is divided. So 25 over 4 divided by minus 5 over 4. So this is equal to 25 over 4. And we said if we want to divide the fraction by another fraction, what do? The first thing is to change the division sign to multiplication sign. So the divide here becomes what? It becomes times, right? And the next thing is that the fraction after the division sign, we invert the fraction. We invert it. That is, the 4 comes up and 5 comes down. It becomes minus 4 over 5. Yes, that's how we divide by fractions. So we move forward. So we can divide there's a minus sign here. So 4 divided by 4, so we have 1, 1, right? 25 times minus 1 is minus 25. And the 1 times 5 is 5. Remember we said if you want to multiply two fractions, you multiply numerator by numerator, and also the number at the bottom by the number at the other bottom. 1 times 5, 25 times 1. That's how we multiply two fractions. Here also 5 divided by 5, 1, and then 5 in 25 is 5. So we have 5. That's minus 5 over 1, and that's minus 5. If you have any number divided by 1, it is equal to that number. 10 over 1 is 10. 2 over 1 is 2. So that's the answer to the first question. Second question, we also want to simplify. We want to simplify 6 whole number 1 over 5 minus 2 whole number 3 over 4 plus 1 whole number 1 over 6. Right? So we can see we have mixed numbers, 3 mixed numbers. So what we do is we convert each mixed number to an improper fraction. And we already know how we do that. 5 times 6, 30, plus 1, 31. 31 over 5. Then minus, here also, the numerator here, times the whole number. 4 times 2, 8, plus 3, 11. 11 over 4. Then plus 6 times 1, 7, plus 1, 8. 8 over 6. Now that we've converted that, we are left with adding. Now, so what we want to do now is we want to find the LCM of the denominators, right? We want to find the LCM. LCM of 5, 4, and 6. LCM of 5, 4, and 6 is what? So I have the LCM of 5, 4, then 6. So here we can divide by 2 here. We have 5, 2, 3. We can still use 2. We have 5, 1, 3. We can still use 3, 5, 1, 1. Then finally 5, 5, 1, 1, 1. So when we multiply these numbers, 2 times 2 times 3 times 5. There's a mistake here. Here we have 2, we have 3. We have another 2 here, 5, 5, 2, 2, 1. So you still have 3. Then here also for 3, we have 5, 1, 1. And finally for 5, you have 1, 1, 1. So that's 4 times 3 times 5. So the LCM is 60. The LCM is 60. Right? So the LCM is now 60. What do we now do? We already know how we used to do it. 60 divided by 5, that's 12. 12 times 31, 372, minus 60 divided by 4, 15, times 11, 165, plus 60 divided by 6, 10, times 8, 80. Let's simplify. 372 minus 165 plus 80. That's 287. 287 over 80. 287 over 80. That's the answer. In improper fraction, if you wish, you can convert it to mixed numbers. And then how do we do that? So let's divide. 287 divided by 60. So you have something like 4.78333. So that means the whole number part there is what? Is 4. That's meaning. Anytime you divide 287 by 60 and then you have 4.78333. That means that 4 there is the whole number part. 4.7833. What do we now do next? To know the remainder, what do? We now say 60 times 4. Exactly. That's 240. Right? We now say 287 minus 240. Start multiplying 60 by 4 because this 60 is the whole number there. So 60 times 40 to 240. Now 287 minus 240. That's 47. So that's 47. That 47 is the remainder. 47 whole number. Sorry, 4 whole number. 47 over 60. 47 there is the remainder. So this is how we convert to mixed numbers. So we have 27 over 60 or 4 number 47 over 60. The third one, 1 over 3 minus 1 over 6 over 1 over 3 plus 1 over 6. We already have proper fractions here. So we just have to add and subtract. For the numerator, so we have 1 over 3 minus 1 over 6. LCM of 3 and 6. You can see that 6 is a multiple of 3, right? 3 times 3, 3 times 1, 3, 3 times 2, 6. 6 is a multiple of 3. That means the LCM of 3 and 6 is what? Is 6. Because we said if you have two numbers, you must find the LCM. And one number is a multiple of the other. The LCM is the higher number. And that's 6 in this case, 6. So 6 divided by 3, 2 times 1, 2. minus 6 divided by 6, 1 times 1, 1, then over. At the bottom also, you have 2 plus 1 over 6. Why? Because at the numerator, you have 1 over 3, 1 over 6. Here also 1 over 3, 1 over 6. So we should have the same number. So the sign will change. Yes. You have minus here. You have plus, minus, plus. But then the number should be the same. 2 minus 1, 2 plus 1 over 6 over 6. To simplify for that, 2 minus 1 is 1 over 6 over 2 plus 1 is 3. 3 over 6. So this becomes 1 over 6 divided by. So the over here becomes divided by 3 over 6. And that's 1 over 6. So what do we do? Division becomes multiplication sign times inverse the fraction. The one after division sign. It becomes 6 over 3. 6 goes up, 3 comes down. 6 divided by 6, 1. 6 divided by 6, 1, right? 1 times 1, that's at the numerator side. 1 times 1, that's 1 over 1 times 3. 3. You have 1 over 3. That's the answer. Now we move to word problems. We move to word problems. And that's what we have here. Word problems on fractions. So in our everyday life, there are some problems we encounter. And those problems can only be solved using fractions. So we will try to interpret the problem into what? Into fractions. And then we now solve the fraction. With that, we can get a solution to the problem. The first one we have here. A man spends 3 over 8 of his salary on rent. So the man spends 3 over 8 of his salary on rent. And 1 over 5 on food. If he earns 80,000 naira, how much does he have after paying for rent and food? How much does he have after paying for rent and food? So you can see his salary is how much? 80,000 naira. Right? And he spent 3 over 8 of his salary on food. That means he spent 3 over 8. A fraction of 3 over 8 of his salary on what? On rent. So fraction spent on rent. Or we cannot say amount spent on rent. Amount spent on rent is how much? 3 over 8 of his salary. That is 3 over 8 times his salary, 80,000. Then 8 in 80,000, that's 10,000. 3 times 10,000 is 30,000. 30,000 on rent. And 1 over 5 on food. Also, amount spent on food. Amount spent on food equals 1 over 5 of his salary. That is 1 over 5 of 80,000. So 5 divided by 5, 1. 5 in 80,000, that's 16,000. 16,000. That's 16,000. 1 times 16,000, 16,000 on food. How much does he have after paying for rent and food? So the amount he has left. That's very simple. He earns 80,000 monthly and he spends 30,000 on rent and 16,000 on food. What do? We simply subtract. We say 80,000 naira minus the 30,000 naira he spent on rent minus the 16,000 naira he spent on food. That should amount to 80,000 minus 46,000. This is equal to 34,000. After spending that amount on rent and food, so he has 34,000 left. You simply find the fraction, the amount, that 3 over 8 of his salary is, and also the amount 1 over 5 of his salary is, you add the two, then you now remove it from the total amount he earns monthly. This is quite a simple problem. Let's move to more technical ones. A trader, or let's just leave this question. It is more related to commercial mathematics than fractions. So we can get to know better when we get to commercial mathematics, where we will discuss discount, profit and loss, installment, and the likes. During a football match, 2/9 of the spectators supported team A, 1/3 supported team B, and the remaining 10,000 were neutral. How many spectators were present at the match? So in a football match, 2/9 of the spectators supported team A, 1/3 supported team B, and the remaining 10,000 supported were neutral. How many spectators were neutral? We are the present at the match. So the first question here is that how many spectators were at the match? Now we said in the very first video we did on fractions that a fraction is a part of a whole. That is, you have a whole, then you take part of it. That's a fraction. So anytime you are dealing with what problems on fraction, it's always good to know what the whole is, what the whole represents. For example, in the previous question, the whole was what? The man's salary. That's the whole. It's from salary, you are trying to take other things out, rent, food, but the salary is the whole. In this question, the spectators, they are the whole, right? So they are the whole. So let's try to figure out how many they are. So for now, we do not have any information about the number of spectators. That means it is unknown. It is not given. That's the first thing to do. Try to figure out what the whole is. So it is from that whole you are trying to take some other parts that are the fractions. So we can say spectators. They are what? X. Or let's just say number of spectators. Number of spectators. So that's X. We do not know them yet, right? But then 2/9 of the spectators supported team A. So 2/9 times what? Times X. Supported team A. When you say 2/9 of something, that is 2/9 times that thing. So 2/9 of the spectators, that is 2/9 times the spectators. And I said they are how many? They are X. We don't know the number, so we use X to represent their number. So 2/9 times X supported team A. 1/3 supported team B. 1/3 times X supported team B. And 10,000 were neutral. That means after we have 2/9 of the total spectators and also 1/3 of total. So the amount left is 10,000. So 10,000 were neutral. 10,000 spectators were neutral. Did they support team A? Neither did they support team B. So what do we do now? How do we find X? Now take note that the total number of spectators is equal to what? Is equal to the number of them that supported team A, the number of them that supported team B, and the rest that were neutral. For example, I say in a class, there are boys and girls, right? So if I want to know the total number of students in the class, what do? I will add the number of boys to the number of girls, since they are the individual entities that make up that class. So it's the same case here. I have to say number of them who supported team A, those who supported team B, and those that were neutral. So if I add all of them, they should be equal to the total number of spectators in the match. So let's see. Those that supported team A, they were 2/9x, right? 2/9x. That's the fraction. Even though we don't know their number now, but we know the fraction of the total they represent. 2/9x plus those that supported team B, 1/3x plus those that were neutral. We know the actual amount, so they were 10,000. So when we add the three categories of people in the match, they should be equal to the total number of spectators, which is X. Which is X. So that is equal to X. So we can now solve this fraction. And the first thing is that let's try to collect like terms. You can see this as X, this as X, this as X. So they are like terms. So we can have 2/9x plus 1/3x, right? Let's take this x to the other side here. So it becomes minus x equal to 10,000 here. Try to take it to the other side here. It becomes minus 10,000. So we've already like times this way. We have all x's on one side and then constants on the other side. So we can proceed. So we have fractions here, right? So this x is just like saying x over 1. Yes, we should know that. So let's find the LCM of 9, 3, and 1. So since 9 is a multiple of what? The multiple of 3 and 1. So we can say 9 is the LCM. We have three numbers, we want to find the LCM. And 9 is a multiple of 3 and 1. So we can say 9 is the LCM. 9 divided by 9 is 1. 1 times 2x. 2x. Take note that the numerator here is not just 2. It is 2x. Let me write it better, in a better way, so you can understand that. So the numerator is actually 2x, not 2 only. The numerator here is 2x. It is 2x over 9 plus x over 3. So you can see it's actually 9 divided by 9, 1 times 2x, 2x. 9 divided by 3, 3 times x, 3x minus 9 divided by 1, 9 times x, 9x equals 10 minus 10,000. Take note, minus 10,000. You can cross multiply. So also we can simplify the numerator here. 2x plus 3x, right, is 5x minus 9x over 9 equals minus 10,000. Of course, multiply. 5x minus 9x is minus 4x, right? Minus 4x equals, of multiply 9 times minus 10,000. That's minus 90,000, right? So we have minus 4x equals minus 90,000. We divide both sides by minus 4, minus 4. So minus 4 cancel out as minus 4. So x now equals, let's divide 90,000 divided by 4. 22,500. The minus also they cancel out. So that means the total number of spectators present at the match. There were how many? There were 22,500. So you can see how we've been able to convert the word problem to fractions, and we'll be able to solve the fraction with the knowledge we have on fractions. So we have this. The next question, so is the question we have here, question number 7 here. A student spends 1/3 of his study time on mathematics. So his study time, he spends 1/3 on mathematics. 1/3 of study time. So it's meant for mathematics. 2/5 of his study time also. Of study time is meant for English. And the rest on science. The rest on science. So the remaining hours. The remaining hours for science. And the question is, how much times does he spend on science? That's the question. So let's see. Okay, yes, if he studies for 6 hours a day, if he studies for 6 hours a day, how much time does he spend on science? Now, so total study time is 6 hours, right? So we want to know how many hours he spent on science. Now, the first thing is to try to find the number of hours he spent on mathematics and English. Since he studies just 3 subjects, mathematics, English, and science. So that means if we can know the number of hours he spent on math and English, we could just deduce that, we could just deduct that from the total time of study he has. So let's see. So the hours for mathematics. That's equals what? 1 over 3. So they said 1 over 3 of the study time. That's 1 over 3 of his study time is 6 hours. 1 over 3 times 6. That's actually 3 divided by 3, 1. And 3 and 6 is 2. 1 times 2 is 2. So it dedicates 2 hours for mathematics. Next to English. So hours for English. So they said that's 2 over 5. 2 over 5 of the study time for English. So and the study time is 6 hours. 2 over 5 times 6. That's equals 2 times 6 is 12. 12 over 5. That's 2.4. 2.4 hours for English. So now we've known the hours is spent for mathematics and for English. So since we also know is total study time, we could just deduce those two from total study time. So hours number of hours is spent on science equals what? Total study time, which is 6 hours, minus the hours it uses for mathematics, which is 2 hours, minus the hours it uses for English, which is 2.4 hours. So we have 6 minus 2 minus 2.4, and that's 1.6 hours. 1.6 hours.